All right, let's begin the practice test review. Okay, when we're doing these problems, remember that unless they ask for a decimal approximation, that you should not give decimals in your answers. Also, you should not have any negative exponents in order to be simplified. Always show all of your work, and for this particular section, we're going to assume that the variables represent any real number. That means that absolute values are going to be necessary. Okay, so let's start. Remember, what we're trying to do is find the perfect cube for problem number 1. So the cube root of negative 27x to the 9th. Look at your list of cubes, and we know that negative 27 is a perfect cube, and you know that x to the 9th is a perfect cube because, remember, for the variables, if their exponents are divisible by the root, the index here, then it is a perfect root. So this becomes negative 3 x to the 9 divided by 3 gives you third power. Now when we check for absolute values, recall that it needs to be even root, even power, odd exponent in the answer. And that's not the case here, so we do not need absolute values around the x. Okay, continuing on with problem number 2, same directions. Square root of 36, well, that's a perfect square, and x squared, since the exponent is divisible by the index, and that index is understood to be a 2 for a square root, this would be 6x. And now when we check for the x to see whether or not we need absolute values, you do even root, even power, odd result. Since the exponent on this x is a 1, it is indeed odd. That means that we do require absolute values around the x. Okay, problem number 3. Notice that we are assuming that we have real numbers, and since this is an even root for number 3, we cannot take the square root of a negative number. Not yet anyway, not under the set of real numbers. So the answer to this is no solution, or not possible, however you want to do that. There is no real solution to that. Okay, number 4. This is a fourth root. So using your list of fourth roots, we want to find out what perfect fourth root factor divides evenly into 243. So when I did that, I came up with the number 81 times 3. 81 is a perfect fourth root, and there's 3 is not a perfect root, so we'll leave it there. X to the 24th. 24 is divisible by 4. It is a perfect root, so we'll just bring it down. Y to the 4th. 4 is also a perfect fourth root, so we'll just bring it down. And now you've broken up the problem into its perfect and imperfect roots. We'll take out the perfect roots, leave in the imperfect roots. So the fourth root of 81 is 3. We're going to leave in this 3 because it's not a perfect root. X to the 24th, the fourth root of that would be 24 divided by 4 gives you x to the 6th. And then y to the 4th is 4 divided by 4 gives you y to the 1st. So the only thing left under the radical is going to be the fourth root of 3. And now we need to check for absolute values around the x and or the y. So let's check the x first. We need to check here at the original problem. So we have even, even, even. So x does not require an absolute value. Let's check the y's. Even, even, odd, yes. So the y does require absolute values. Okay, the next set of directions for number 5 say rewrite the expressions in simplest radical form. Notice they're in exponential form now, meaning they have an exponent. We want to convert that to a radical. If you recall, the denominator of the exponent refers to the root, and the numerator refers to the power. So the first thing I want to do is get rid of the parentheses by raising power to a power. So remember, this is 16 to the first power, so that's going to be 1 times negative a half gives you negative 1/2. So that's 16 to the negative 1/2 power. X, negative 4 times negative 1/2 is positive 2. and y, 6 times negative 1/2 is negative 3. Now recall that we want to convert it to a radical, and we also, if necessary, will refer it to a radical. And then of course we're going to change the negative exponents. They cannot be there. So recall that we're going to remove this and move it down, and we're going to take this and move it down. Negative exponents, you need to move them. If they're negative in the numerator, move them to the denominator. If they're negative in the denominator, you'll move them up to the numerator. So this becomes x squared stays in the numerator. Its exponent was positive. 16 moves down and its exponent becomes positive 1/2. Y to the negative 3 moves down and its exponent becomes positive 3. Okay, so the only thing that needs to be converted to radical form would be this 16 to the 1/2, which of course we know means the square root of 16 to the first power. And of course that's a perfect root, so that would be x squared over 4y cubed. And that would be your final answer in simplest radical form. As it turns out, we didn't need any radicals in our answer. Okay, let's try B. Remember that the denominator requires, that means the root, and the numerator is the power. So this negative, since it's inside the parentheses, will be under the radical. So this becomes the 5th root of negative 32x to the 10th, and all of that will be raised to the 4th. So since this is an odd root, we can take the odd root of a negative number. So the 5th root of negative 32 is negative 2. The 5th root of x to the 10th, remember 10 divided by 5 gives you x to the 2nd. And all of this is to the 4th power. And now raise each to the 4th power, so negative 2 to the 4th power becomes positive 16. And x to the 2nd to the 4th power to a power you multiply becomes x to the 8th. And that's the answer.